Welcome to today's YouTube live webinar. So, thank you for taking time to join me. Whether a student, a beginner CNC machining, a CAD designer, or simply curious about how modern machines work, you are in the right place. Today, we are going to explore one of the most important foundations of manufacturing technology: coordinate systems and axis concepts. At first glance, this topic may sound technical. You might even think it involves complicated mathematics. But I promise you, by the end of this webinar, you will realize it's actually based on something we use every single day: finding locations. Like, think about opening Google Maps. If you want to reach a destination, the app needs an exact location. Saying, take me near somewhere near the supermarket isn't enough. It needs a precise point. CNC machines work in exactly the same way. A CNC machine doesn't understand words like move a little left, go slightly forward. Instead, it understands positions using coordinates and axes. These coordinates tell the machine exactly where to move, how far to move, and in which direction to move. So, throughout this session, we will build these concepts step by step using simple examples, real CNC applications, and everyday comparisons. My goal isn't just to help you remember these concepts, but to help you truly understand them. Once you do, learning CNC programming and CAD will become much easier. So, let's begin our journey into the language that every CNC machine speaks. So, why does a CNC machine need coordinates? So, CNC machine use coordinates just like our humans. It uses it uses the coordinates to know where it is or where it needs to go or how far it should move, which direction it should move, or its current position. All these things are calculated by the coordinates. So let's dig deeper into this. So before we learn about coordinate systems, let us compare how humans find location and how CNC machines find locations. Suppose you want to visit a friend's house for the first time. Normally, you would use landmarks. You may say, okay, near the bus stand, near the railway station, or opposite to a shopping mall. Humans use landmarks to identify locations, but machines cannot understand landmarks. Machines need exact reference point. Think about the directions. Humans use directions like north, south, east, west, southwest, east, southeast, all those things. But machines uses the axis. Instead of saying go north, the machine receives instruction move in this axis, move in the other axis. Then comes distance. Humans often estimate distances. We may say walk about 100 meters, but machines do not estimate. Machines move exact distances. For example, move one. If I say move 125 mm, it means that it is 125.00 mm, not 124.9 or 125.1. Exact 125. Now, think about navigation. Humans use maps or GPS. Machines use coordinate system. A coordinate system acts like a map for the CNC machine. It helps the machine identify every position within its working area. Finally, GPS in a mobile phone continuously update your current location. Similarly, the CNC machines constantly monitor their positions using the feedback devices like encoders or sensors. And these encoders and sensors tells the control where the axis is located. So this is why when you look at the CNC, you always see the axis positions changing during the movement. So in short, humans and CNC both need location information. The only difference is that the CNC needs more higher precision. So, so we knew why we need a coordinates. Let's understand what a coordinate system is. In simple words, a coordinate system is a method used to identify the exact location of a point. Like, imagine a chessboard. Every square has a unique location. If I say E4, every chess player knows exactly which location or which square I am talking about. Similarly, in a city map, every building has an address. That address helps us to identify the exact location. A coordinate system works in the same way. It allows us to identify the exact position of any point within a defined area. For a CNC machine, this area is machine's working envelope. Every position inside the machine can be represented using the coordinate values like X, Y, or Z. These numbers tell the machine exactly where the tool or table is located. Without a coordinate system, the machine would have been no way of identifying the positions. It would not only know where the spindle is, it would not only know where the workpiece is, it would not know where to move next. So it is like a machine's internal map. Every movement, every operation, every tool path, every position is based on this map. This is why coordinate systems are considered the foundation of CNC technology. Before a machine can cut, drill, mill, or tap, it must first know where everything is located and where it has to be done. And that knowledge comes from the coordinate systems. Now that we understand what coordinate system, let us look at a specific coordinate system used in CNC machines. Almost all CNC machines use what is known as the Cartesian coordinate system, which was developed by a French mathematician named René Descartes. No need of remembering the name, but it's interesting to know where the concept originated. The Cartesian coordinate system uses axes that are positioned at right angles to each other. These axes allow us to define any point in space using numerical values. In a simple two-dimensional system, we use two axes, x-axis and y-axis. But CNC machines use three dimensions, so thereby we use the x-axis, y-axis and z-axis. Together, these three axes can identify any position within the machine's working area. Think about a room. It will tell you move 3 meters to the right, 2 meters to the front, and 1 meter up. You can identify a very specific location inside the room. The CNC machine works in exactly the same way. The combined X, Y, and Z values, the machine can determine the precise location of the tool or the workpiece. This is the foundation of CNC motion. Without this system, accurate CNC machining would never be possible. So, where does the coordinate system begins? Imagine you want to measure the length of the table. Where do you start measuring from? You need a starting point. Without the starting point, the measurement has no meaning. The same principle applies to coordinate system also. Every coordinate system requires a reference point from which all measurement begins. This point is called the origin. The origin is represented as x0, y0 and z0, or simply 0, 0, 0. Think like it is a birthplace of all the coordinates. Every position in the coordinate system is measured relative to this point. If a point is located at x100, that means that it is 100 mm away from the on the x-axis away from the origin. So without the origin, these numbers would have no meaning. So for example, if you want to know the distance, we are just telling what is the distance to Chennai. So if we tell what's the distance to Chennai, we should know from where I have to take the measurement, whether it's from Bangalore or Coimbatore or Cochin or Mangalore. We have to know from where the dimension has to be taken or where the measurement has to be taken. So the initial point where the measurement starts is known as the origin. Now, when we say machine moves from one position to another, how exactly does it move? The answer is through axis. An axis is simply a defined direction of movement. A CNC machine is also capable of movement, but instead of using words like forward or backward, it uses axis. And these axes provide a standard way of defining movement. In most CNC machines, we have three primary linear axes: the x axis, the y axis, and the z axis. Only then can we reach the exact location. That is why axis and coordinates work together and is very important. Coordinates tells us the location and axis provides the direction needed to reach that location. Without axis, coordinates would have no meaning. And without coordinates, axis would not know where to move. The two concepts always work together. Ah, Let's see. Let's begin with the first axis, the x-axis. It is most important axis in any CNC machine. It represents the horizontal movement. Depending on the machine design, the movement may occur through table movement, saddle movement, or spindle movement. The important thing to remember is that the x-axis always represents a specific horizontal direction within the machine coordinate system. When the machine moves along the x-axis, the x coordinate value changes. So in this move, only the x value changes. The other values stay same or it remains unchanged. This is because CNCs move by changing coordinate values along the specific axis. So if you see, the x-axis is always from left to right movement. The left to right movement is known as x-axis. Now, next is the y-axis. The y-axis represents movement in the front and back direction. So, in most of the vertical machining cases, the y-axis movement occurs either by moving the saddle or table, depending on the machine design. A simple way to understand the y-axis is to imagine yourself standing in front of the machine. If the movement happens towards you or away from you, that movement is generally associated with the y-axis. So, to reach a location, you may need movement in the x and y axis. So, both these x and y axis work together to position the tool anywhere on the surface of the workpiece. Next, we have the z axis. The z axis represents the vertical movement. So, in a typical VMC or the vertical machining center, the z axis is usually a spindle movement. When the spindle moves upward, it moves along the z axis. When the spindle moves downward, again it moves on the z minus axis. The z axis is extremely important because it controls how deep the tool enters the material. Like a simple drilling operation, we first position using the x and y, and then the z axis takes over. It will go deep into the workpiece. Now, we learned about the x, y, and z axis. But have you ever wondered why these directions are defined this way? Why isn't the x axis pointing somewhere else or z axis in different direction? The answer lies in simple and internationally accepted method called the right hand rule. This rule not only uses CNC machine but also in CAD software, CAM softwares, robotics, engineering, and even physics. It ensures that engineers around the world follow the same standard when defining directions. So if you hold your right hand in front of you, stretch your thumb, index, and middle finger so that each points a different direction, making them perpendicular to each other. Your thumb represents the positive x-axis. Your index finger represents the positive y-axis, and the middle finger represents the positive z-axis. These three directions form the three-dimensional coordinate system used by the CNC machine. Think of this as a universal language. Whether you are working on a CNC machine made in India, Germany, Japan, or US, the machine follows the same axis conversion. This common standard allows the CAD models, CAM programs, and CNC machines from different manufacturers to work together accurately. So whenever you are unsure about axis directions, you don't need to memorize them. Simply raise your right hand and let your finger guide you. It's one of the easiest and most reliable ways to remember the directions of X, Y, and Z axis. So now we have learned X, Y, and Z axis separately. However, in real CNC machines, these axes rarely work independently. Most machining operations require two or more axes to move together. Let's understand with a simple example. Imagine a drill bit positioned above the workpiece. To drill a hole at particular location, the machine first needs to position the tool correctly. The x-axis moves the required left-right position. The y-axis moves the required front-back position. And once the current location is reached, the z-axis moves downwards to perform the drilling operation. All the three axes work together to reach the target point. Now in the milling operation, suppose the machine has to cut a pocket or a machine counter. The tool may move continuously in X and Y while simultaneously moving in Z. This allows the machine to create complex three-dimensional shape. So a CNC machine combines axis movements to produce accurate operations. This is why CNC machines are so powerful. Instead of moving only on straight lines, they can follow complex tool paths by coordinating multiple axes at the same time. As now, since we have learned the CNC machines move in X, Y, and Z axis, but there is another important question. How does the machine know which way to move? So if I tell move 100 mm in the X direction, the machine will ask which X direction, left or right? Or when the movement in Y, which direction, forward or backward? Z, up or down? This is why every CNC axis has two directions, a positive direction and a negative direction. So if the movement occurs in positive X direction, the X value, coordinate value will increase. If it moves to the opposite direction, the X value will reduce. So you can see here, towards the right, it is X positive. Towards the left of the origin, it is X negative. Towards backside, it is positive. Towards forward, it is negative. Towards up, it is positive. And towards down, it is negative. So we have X plus X minus, Y plus Y minus, and Z plus and Z minus. Now, the next step is understanding how these three axes work together to identify a single position. So think of coordinate as an address. Suppose somebody gives you only a house number. Can you find the house? No. Suppose they give you house number, street name, city. Now you have enough information. Similarly, a CNC machine needs information in all three directions. Like for example, X100, Y50 and Z25. That means 100 mm has to be moved in X-axis from origin, 50 mm along the Y-axis from origin, and 25 mm along the Z-axis from origin. The point reached after these three movements is exactly the location represented by these coordinates. So next is so till now we have discussed the three primary linear axes X, Y, and Z. These axes provide the straight line movement. However, modern CNC machines are capable of much more than simple linear movement. Many advanced CNC machines also have rotary axes. As the name says, rotary axes provide rotational movement. So instead of moving a straight line, a rotary axis rotates along and around another axis. The A-axis rotates around the X-axis and it is called the roll. The B-axis, which rotates around the Y-axis, is otherwise known as pitch. And the C-axis that rotates around the Z-axis is known as yaw. So just understand that these rotary axis adds rotation to the machines, like holding a component in your hand. Now, Since we are known about the linear axis and rotary axis, let us see how CNC machines are classified based on number of axes they have. The most common machines found in industry are the three-axis machines. The three-axis machines uses X, Y, and Z. These machines are suitable for large percentage of machining operation and are widely used in manufacturing. Then comes the fourth axis machine. The fourth axis machine contains the three linear axes plus one rotary axis, usually the A axis. This allows the workpiece to rotate, enabling machining on multiple sides without removing or reclamping the component. Then we have the fifth axis machines. These machines contain X, Y, Z plus two rotary axes. The five axis machines can produce highly complex parts with exceptional accuracy. Industries such as aerospace, medical, defense, precision engineering heavily use five axis machines. As a service engineer, you may encounter all these machine types during your career. Now, let's see where these coordinate systems are used. So, coordinate systems are not limited to just CNC machining. In fact, they are used in many technologies that we interact in our everyday. Let's begin with CAD software like SolidWorks, AutoCAD, CATIA, NX, Rhino, anything. Whenever you create a sketch, draw a line, or model a part, every feature is placed using the X, Y, and Z coordinates. Without the coordinate system, the software wouldn't know where to create or position your design. Next comes the CAM software. After designing a part, CAM software uses the same coordinate system to generate tool paths for the CNC machine. It converts your design into precise movements that the machine can follow. In industrial robot, when a robotic arm picks up a component and places it somewhere else, it moves to exact coordinate positions. Every movement is calculated using the same principle we have learned today. Now about GPS navigation. When you use Google Maps or navigation system, your location is identified with coordinates. The fascinating part is that although these technologies look completely different, they all speak the same language, coordinates. So once you understand coordinate system, you are not just learning CNC, you are learning a fundamental engineering concept that connects manufacturing, design, automation, robotics, navigation, and many other modern technologies. So that is the reason why this topic is considered one of the most important foundations in engineering. It's a skill that will stay with you throughout the year. So let's see what are the key takeaways of today's webinar. First thing, every point has a unique location. X, Y, Z axis defines the machine movement. The right hand rule standardizes axis directions, and coordinate systems are the foundation of modern engineering. So we have now reached the end of today's webinar. Thank you so much for joining me and spending a valuable time learning about this. I truly hope this session has given you a better understanding of how coordinates work. If today's webinar has inspired you to build a career in CNC machining and manufacturing, I'm happy to let you know that the enrollments for batch 7 of a 45 days CNC Operator Cum Program course have now started. This is a comprehensive, industry-oriented training program designed to help students and professionals develop practical skills that are required in today's manufacturing sector with 100% placement assistance. Seats for the upcoming batch are limited and only a few are still available. If you are interested in joining or would like to know more about the course structure, eligibility or admission, please feel free to contact us. I would like to invite you to continue learning with us through our free technical webinar series conducted every Saturday. Every week, we explore new topics related to CNC machining, CAD, CAM, metrology, engineering, drawing, manufacturing technologies, industrial automation, and many more practical subjects. So if you enjoyed today's session, please don't forget to subscribe to our channel and enable notifications so you never miss an upcoming webinar. Once again, thank you for your time, your support, and your enthusiasm for learning. This is Pia Shartnampia, Technical Training signing off. Until we meet again, keep learning, keep innovating, and keep building the future. Thank you all and have a wonderful day.